Hello students. Till today we have learned about gravitation, gravitational force, what is gravity, and in our last class I have explained you what is acceleration due to gravity. Now I would like to recall a little bit. What is acceleration due to gravity? The acceleration with which a body falls towards the earth due to Earth gravitational pull is known as acceleration due to gravity. It is denoted by small g. For example, if you take a pen on your hand, if you leave the pen simply, then with some speed it will fall towards the earth. That speed is known as acceleration due to gravity. That speed is your acceleration due to gravity, which will be denoted by small g. The value of acceleration due to gravity, this g is equal to 9.8 Newton. It is 9.8 Newton generally, or sometimes we are writing as 10 meter per second, or 9.8 Newton or 9.8 meter per second. We are writing it as 9.8 meter per second, or sometime in a whole we are writing 10 meter per second. That is the value of acceleration due to gravity. Now, factors on which acceleration due to gravity depends. Now, on which factors this acceleration due to gravity will depend? Number 1, acceleration due to gravity is directly proportional to the mass of the earth. This small g, you can see the formula from here. If I will show you, at first if you see force equal to mass into acceleration, you know F equal to ma, then F equal to g m1 m2 by r square we have found out in the last video. Then if you will cancel out, if you will compare here, then you will get a new formula, that is acceleration a equal to gmm by r square, that a equal to gmm by r square. If I will cancel out, see, if this small m and here small m cancel, then a equal to g capital M by r square, that a equal to g capital M by r square, or this g capital M by r square is known as small g, is known as acceleration due to gravity. That means the acceleration due to gravity is directly proportional to the mass of the earth. It is directly proportional to the mass of the earth. You can see g is equal to gm by r square. Capital M is the mass of the earth, and it is inversely proportional to the square of the radius of the earth, and this r is the square of the radius. It is inversely proportional to the square of the radius of the earth. That means acceleration due to gravity depends on radius and the mass of the earth. If the mass increases, then acceleration due to gravity increases. If the radius increases, then acceleration due to gravity decreases squarely. Now, what is free fall? The falling body of which only force of gravitation of the earth act is known as free falling body, and such fall is known as free fall. A freely falling body has acceleration equal to acceleration due to gravity. What is free fall? Free fall, I have told you in the last slide that if you leave a pen simply, then it will fall with some speed. That fall is known as free fall, and that acceleration is known as acceleration due to gravity. Without any force, if you leave anything from a height and it goes towards the earth, then this fall is known as free fall, and the speed attained by the object is known as acceleration due to gravity. A freely falling body has acceleration equal to acceleration due to gravity. I have told you that acceleration due to gravity. I hope you have understood. Now you can see in the picture, some people are gliding on the sky. If you have skydiver, have you ever seen any skydiver in any movies? You can see that some people jump from the aeroplane, and then with the help of their body they just freely fall on the sky. That picture denotes the free falling of an object. Now, mass and weight. Mass means what? Mass of a body is defined as the quantity of matter contained in the body. Mass means how much quantity of matter it has in a body. For example, if you take a football, that means big football, if you take, how much space it will take, that space doesn't mean its entire mass. That space is not its mass. The mass of the object is how much material or how much matter it have. That matter is known as the mass. That inside the football it is empty space. That empty space is not the mass. Only the body, only the circumference of the football is the mass. That is the matter. Since mass of a body is measure of inertia of the body, so mass is known as inertia mass. The unit of mass is kilogram. The unit of mass is kg, kilogram. What is weight? The force with which the body is attracted by the earth is known as the weight of the body. With what force any object is attracted towards the earth, that is known as the weight of the body. We can denote as W equal to M mass into G, gravitation acceleration due to gravity. That weight equal to mass into gravity, W equal to mg. The force with which W weight means the force, weight equal to the force equal to weight equal to mg. The force with which the body is attracted by the earth is known as the weight of the body. Now what is the difference between mass and weight? You can note it down. See, number 1, mass of a body remain constant. Always mass will be constant. Weight of a body changes from place to place. If you go in water and you weight yourself, then you will get your weight is less. If you go on moon in the space, if you get your weight on, if you measure your weight, then your weight will be less, but your mass will be constant. Mass of a body is never zero. Weight of a body at the center of the earth is 0. Mass is a scalar quantity, weight is a vector quantity. Mass is measured in kg, weight is measured in kg weight or Newton. Mass is measured by a beam balance. Weight is measured by a weighing machine or spring balance. So I hope you have understood the difference between mass and weight. Now these are some important notation. You can see radius of earth, you can write it down. The radius of earth is 6.4 into 10 to the power 6 meter. Mass of earth is 5.98 into 10 to the power 24 kg. Gravitational constant, that is capital G, equal to 6.673 into 10 to the power minus 11 Newton per meter, Newton meter square per second square. Small g, acceleration due to gravity, equal to 29.8 meter per second, or we can, there is small correction, it is 9.8 meter per second. It is not 29.8, it is 9.8 meter per second. That small g, acceleration due to gravity, is 9.8 meter per second. And acceleration on the moon, and if you will see this acceleration on the moon, that is g of moon is 1 by 6 of g of earth. That is 1 by 6 into 9.8 by a of earth. It is the moon acceleration due to gravity is 1 by 6 of acceleration due to gravity of earth. These are some important notation I have shown you, and from our next class we will start discussion of mathematical problems and some other topics of this chapter. So I hope you have understood till this much, and if you have any confusion you can contact me. Thank you.